Yeah, you can start putting your attendance in the chat box, something like in this format. Okay, roll number plus name, roll number as well as name. The format I have already typed and I have sent. Let me present my screen. Is it visible, the screen?
Yes, sir.
Okay. Are you okay with this color combination? I mean, it is legible, right?
Sir,
Yes,
it is kind of not visible.
Not visible.
Can you also zoom in a little?
Pardon me?
Can you zoom in a little?
Okay. Now, is it fine?
Yes, thank you, sir.
Yeah. So what I will do, I mean, in the beginning only you have to tell me, okay, whether it is visible or not. Based on your, requirement, I can increase or reduce the font size as well also. All right. So other day we were discussing about series and parallel combination of resistances, right? We derived an expression for equivalent resistance if the resistors are connected in series. Also, we had found an expression for equivalent resistance when the resistors were connected in parallel. Okay. Now, based on the understanding of series circuit and parallel circuit, okay, let us derive two more rules. The first rule, okay, is called as the current division rule. Current division rule. In short, it is called as CDR. Okay. Now, this current division rule, okay, it is based on a parallel networks. Okay. So it is based on parallel network. Okay. Now, that is one thing. Okay. That is, it is based on parallel network. The second thing is that this current division rule, holds good for only two resistors connected in parallel. Okay, when there are more than two resistances, okay, we can go for the conventional approach, that is reduction of 3 or 4 resistors into a single resistance using parallel reduction technique. Okay, so on and so forth. But when there are two resistors connected in parallel, one can even choose a current division rule while solving the problems. Okay, all right. So let us consider two resistors. Okay, namely R1 and R2 connected in parallel. Say R1, say R2, connected in parallel across a battery having a potential of V volts. Okay. Let I be the main current and I1 and I2 be the branch currents. I is the main current. Okay, let me write. I is equal to main current. I1 and I2 are branch currents. All right, fine. Now, by looking at the circuit, okay, you can make out that it's a parallel circuit, and in case of a parallel circuit, the terminal voltage across the passive device remains the same. So the current which is flowing through resistance R1, okay, is I1, and I1 can be found using Ohm's law, right? voltage divided by resistance. So what is the voltage which is coming across R1 is V volts divided by the resistance. All right. Similarly, you can say I2 is equal to V by R2. Okay, V by R2. Then also we have seen that R equivalent for a parallel connected resistance, okay, is R1 into R2 divided by R1 plus R2. Okay, let's say these two are first set of equations and this is equation 2. Okay. Then the battery potential V, okay, can also be written in terms of R equivalent, that is voltage V, okay, is equal to I into R equivalent. Okay, in the sense I can reduce this circuit into a simple circuit having a single resistance value R equivalent, which is basically representing the two resistors connected in parallel. Okay, the battery having volts V and the main current which is getting circulated through the resistance are equivalent. Okay, so by looking at this equivalent circuit, you can say that the terminal voltage V is I into R equivalent. Okay, let's say this is equation 3. Okay. So what you can do is you can substitute equation 2 in equation 3. Okay. So what do you get? You get V is equal to I into R equivalent. What is R equivalent? R1 into R2 divided by R1 plus R2. Okay. Or, okay, you're getting it, right? V is equal to I into R equivalent. Okay, where R equivalent is given by equation 2. Okay, so you would get V is equal to I into the respective, R equivalent value. Okay, now in equation 1, you have written I1 is equal to V by R1 and I2 is equal to V by R2. So basically what we are trying to do is that we are trying to equate, equation 1 and equation, say, 4. Okay, that's because in equation 1, if you do the cross multiplication, you can get V is equal to I1 into R1. Similarly, V is equal to I2 into R2. Okay, so what I will do from equation 1, we can write voltage V is equal to I1 into R1, and voltage V can also be given in terms of I2 into R2. All right, so what I've done, I've just done the cross multiplication. V is equal to I1 into R1 and V is equal to I2 into R2. Okay, so let's say this is equation 5. So equation 5 and equation 4, they both represent the voltage. So you can equate. So equating 4 and 5 will give you I into R1 R2 divided by R1 plus R2 is equal to I1 into R1. Okay, so what happens is that R1 and R1 gets cancelled. So I1 is basically, okay, I1, I'm going to write it on the left hand side. So I1 is what? I1 is equal to main current I into opposite branch resistance divided by sum of the resistances. Okay. Similarly, in place of V, okay, for this particular equation, in place of V on the left hand side, you can write I into R1 R2 divided by R1 plus R2 equal to, okay, what is it? Right hand side term. It is I2 into R2. So basically, R2 and R2 you can cancel out, okay? And you're left with I2 is equal to, again, main current, which is I, into resistance of the opposite branch divided by sum of the resistances. Sum of the resistances, okay? So simple rule, okay, which talks about the division of current. Okay, so in words, you can say that branch current is equal to main current into opposite branch resistance divided by total resistance. Right? So, for example, branch current I1 is equal to main current. What is the main current? Main current is I into opposite branch resistance. So, for I1, what is the opposite branch resistance? It is R2. Okay, R2. So opposite branch resistance going to be R2 and total resistance is R1 plus R2. So this is how you can apply the branch current formula. Okay. Few people will find it handy while solving the problems. Few people, they'll just go with the conventional method, that is series parallel reduction. Doesn't matter, but I had to discuss about it. Okay, so it is up to you to choose whether to choose branch current formula or whether to go with the classical approach, that is finding out R equivalent, then divide the voltage, okay, with the resistance value, find out the current, then you add up the two currents to get the main value of current, etc. Let us discuss both the approaches, okay, the conventional approach as well as the branch current approach. Okay, whichever you find it easy, you can use it in your future classes. Okay, so that's the first rule, which talks about division of current. Okay, now when you have division of current, you can also have the other variant, right? That is the division of voltage. So the second rule talks about voltage divider rule. In short, it is called as VDR. Okay. Okay. Any guesses which kind of circuit we may have to use? The circuit, yeah,
Series circuit.
Series circuit.
exactly. So in series circuit, the terminal voltage across the resistor changes, right? So series circuit, you are supposed to use it. Okay. So even this voltage divider rule is generally applicable to two resistors connected in series. Okay. When there are more resistors, you don't go for voltage division rule. Instead, you combine them into a single resistance. Okay. So let's consider two resistances connected in series. Let's say R1 and then let's say R2. Okay. They're connected in series across a battery having potential V volts. Okay. All right. So let I be the current which is flowing through the circuit. Okay, the same current I flows through R1 as well as R2. But when the current I flows through R1, okay, it gives a voltage drop of V1 across resistance R1. Similarly, when the current I flows through resistance R2, it gives a different voltage drop, let's say V2, across the terminals of R2. Okay, across the terminals of R2. The equivalent resistance, you can write it as R equivalent is equal to R1 plus R2. So from the previous discussion, you can say that R equivalent is R1 plus R2. And also you can write that V is equal to I into R equivalent. Okay, V is equal to I into R equivalent. Okay. And voltage V1, you can say that it is I into R1. Similarly, voltage V2, you can say that it is I into R2. I into R2. Okay. Try out now. So we have written down the equations. Okay. Try you are able to build a relationship between voltage V1 and V in terms of resistances. Similarly, try to build a relationship between, the branch voltage V2 with the main voltage V, in terms of some resistances. Okay, so some x by y form you are going to have it. Okay, please try it. Please try it from you. Give about, say, 3 minutes of time. Okay, and then you can tell me the answers.
Sir, V is equal to V1 plus V2.
Right, V is equal to V1. That's correct. Because
V1 equals V into R1 by R1 plus R2.
so in case of
V1 is equals to R1 by R equivalent into V.
So V1 is equal to V into R1 divided by R1
R
plus
equivalent.
right, R equivalent. On the other hand, V2 is equal to V into
R2 by R1 plus R2.
R1 plus R2. Okay. So if you have obtained, well and good. If you haven't obtained, I would ask you to try it out. Okay. So still, if you don't get it, you can ping me in the WhatsApp group. Okay. I will give you the derivation. This you consider it as a small activity. Okay. So basically, in case of voltage division rule, you can say that branch voltage is equal to main voltage into resistance of, or rather you can say resistance across which branch voltage is measured divided by total resistance So let us say, for example, branch voltage, let us consider V1. Okay. So branch voltage V1 is equal to main voltage. So what is the main voltage? Main voltage is nothing but the supply voltage. Okay. Into resistance across which branch voltage is measured. So my branch voltage is V1 and V1 is measured across the resistance R. So this is going to be R1. So the numerator term is R1 and divided by total resistance. Total resistance is R1 plus R2. So for this particular circuit, it is R equivalent itself because it's a series connected resistance. Okay, so this is how you derive the voltage division rule. Okay, once again, few people will find it favorable. Few people may not find it that favorable. You can use the conventional technique to solve the problems. Okay. All right. Now, remember one thing. Okay, both of these rules may appear in your external examination for about 6 marks. Okay. So this you please try it out. Okay, if you don't get it, just let me know. I'll be able to help you out. Fine then. So I think most of the theory portion related to DC circuits we have discussed. Okay, so what I will do now is that I will start solving the problems. Okay, so you can consider the first problem. Okay, first problem. Okay, please note it down. Anyhow, I'll provide the video recording. Okay, when I dictate, you please note it down. Two resistors, 20 ohm and 40 ohm, are connected in parallel. A resistance of 10 ohm is connected in series with this combination. A voltage of 200 volt is applied across the circuit. Find the current in each resistance so question mark. I'll put question mark. Simply indicates that this is your objective. Okay, your objective is to find current in each resistance. Then voltage drop across 10 ohm. The first one. Second one is voltage drop across 10 ohm resistance. Also find the power consumed in all the resistances. In all the resistances. Are you able to follow me? You could hear my voice, right? Properly. Okay. So this is the problem statement. Okay. See, in basic electrical engineering, there are two ways of asking a particular question. Okay. Either they may give you the circuit directly, okay, or they may give you the statement. Okay. Now, in this particular problem, you can see that the circuit is not being given, right? Instead, the problem is explained in the form of few statements. Okay. So whenever the statements have been given, always remember one thing. When statements are given, okay, you have to frame the circuit, because this particular problem may come for, let's say, 6 marks, in which the circuit diagram, okay, will carry 1 to 2 marks. Okay, 1 to 2 marks. So please draw the circuit diagram from the problem statement. Okay, and the solution, okay, will carry the remaining 4 marks. Okay. Now, when you provide the solution, okay, with the few steps, you can arrive at the right answer. No question asked. Okay, if you get the right answer, nobody will worry about the steps. Okay, the answers are important. Now, let's say you haven't used the steps and you have straight away written the answer. Say branch current I1 is equal to so much, I2 is equal to so much. And if the answers are not correct, then you will be in trouble. Okay. So when the answers are not correct, okay, we tend to evaluate the method. Okay. So even if your answers are wrong, but if your method is correct, then you will be getting close to 40 to 50% of marks. Okay. So always make a habit of providing the intermediate steps also. That's because this exam is considered as descriptive exam, not the objective exam. Okay, in objective exam, nobody will worry about the steps, right? People will be just worrying about the final answers. Okay, since this is descriptive exam, so always try to show at least few steps, so that even if your answers goes wrong, still you will be able to get at least 50% of the total marks. Okay, fine. So having said that, I can start with the problem solution. So my first objective is to frame the circuit diagram. Okay, so let me construct the circuit diagram. So it says two resistors, 20 and 40 ohms, are connected in parallel. So let me do that first. I have two resistors, 20 ohm and 40 ohm, connected in parallel. Okay. A resistance of 10 ohm is connected in series with this combination. That means to say, with this parallel combination, you have a third resistance having a resistance value of 10 ohm connected in series. Okay. A voltage of 200 volt is applied across the circuit. So voltage of 200 volts is applied across the circuit in the sense, let's say I have terminal A and let's say terminal B. Okay, across terminal A and B, 200 volts of voltage is applied. So this is my 200 volts. And you have been asked to find the currents in each resistances. Okay, so let us mark the currents. Say this is I. Say this is I1. Say this is I2. So at this particular node, what will happen? They both add up and they'll come out as I1 plus I2, which is basically I itself. Okay, I itself. And also you need to find out the voltage drop across 10 ohm resistor. Let's say Vx is the voltage drop across the 10 ohm resistor. So you are supposed to find this Vx drop, okay, as well as current I1, current I, and current I2 as well. And finally, you need to find out the power consumed in all the resistances. So to find the power consumption, either you need to know the current value through the resistors, or you need to know the voltage value which is appearing across the resistors. Okay, fine then. So my first part is done, that is the construction of circuit. Okay, now let me take up the solution. Okay, since it's a series parallel combination, okay, what I am thinking right now is to obtain an equivalent resistance. Okay, so what I will do, I will convert these three resistors into a single resistance, R equivalent, okay, connected across a battery having a potential of 200 volts. Okay, and through this R equivalent, current I flows. Okay, so basically I want to find the main current first. Okay, if I can know the R equivalent value, I can find out the main current. Okay, now what is R equivalent? So where R equivalent is equal to, okay, firstly you have 20 and 40 ohms in parallel. So basically it is 20 ohm in parallel with 40 ohm. And that combination gets connected in series with 10 ohm resistance. So this gets added with the 10 ohm resistance. So R equivalent is basically 20 into 40 divided by 20 plus 40 plus 10 ohm. Okay, so that's R equivalent is equal to, okay, $13.33 ohm plus 10 ohm. So that is 23.33 ohms. Okay, 23.33 ohm. Okay. Now, I never spoke about the calculator. You need calculators. Okay. Since it is engineering, you cannot use what you say, the simple accountant calculators. That's because sometime later when you handle AC circuits, you need to handle the complex numbers as well. Okay. So you need to have a calculator which can handle the complex numbers, which can also handle low level of integration, differentiation, okay, and simultaneous equations, etc., etc. So the calculator, what I am going to suggest you is, maker of the calculator is Casio, okay, and the model name is FX 991 ES plus, okay, FX 991 ES plus, okay.
So calculators are allowed in exams.
Oh, of course, yes. Calculators are allowed in engineering. Okay, scientific calculators are allowed. Okay, or you can even go for the same maker, Casio. The series name is, the model name is FX 991 EX. Okay, EX. This is slightly costlier. This is slightly costlier. Okay, you can just compare the prices and you can decide. Okay, either this or this, you go for it. Do not go for any other versions. Okay.
So I have FX 82MS.
Okay. Now with the 82 ms, probably you have chosen statistics in your 12. Correct? No.
No, sir. They just allowed it, sir.
Yeah. Now it is allowed. Okay. See, this is called as, this is the what you say, top model, you can say. Now, why I won't prefer 82 plus is that 82 plus doesn't have complex number features, and it will not even have what you say, simultaneous equation feature. So you will have to do it manually. That's the reason.
Yes, sir.
Okay. If you have something like FX 100, or you do one thing. If at all you have already a calculator, okay, you can just ask me in WhatsApp, okay, whether it is useful or not. But when you ask, please specify the model. Okay, by looking into the model, I will be able to tell you whether you can use it or not. Okay, but remember one thing: there are calculators. They belong to programmable calculator category. Okay, especially this Texas Instruments calculator. They are not allowed. Okay, so remember one thing: programmable calculators are not allowed in exam. At the maximum, you can go for this series. These are non-programmable calculators. Okay. All right. Any doubts? We can carry out in offline discussion. Okay. Fine then. So we have found R equivalent. Okay. Now, having known R equivalent will enable you to find the main current. Okay. So the main current I is equal to V by R equivalent. V is 200 divided by R equivalent is 23.33. So that gives me main current of 8.57 amperes. Okay. Now remember one thing: in engineering, regardless of the course, after the decimal point, at least you maintain 2 digits for accuracy. Okay, don't round it off to, let's say, 8 amperes, or don't even round it off to just 8.5. Okay, at least for accuracy, you keep 2 digits after the decimal point. Fine, that's your main current I. So since it is the first problem, let me write it in words. So current through 10 ohm resistor is 8.57. So therefore, I through 10 ohm resistance is equal to 8.57 amperes. Okay. Now you need to find out I1 and I2. That's all. Now I1 and I2 you can find either using branch current, okay, or you can use once again the division of voltage. Okay. Now what I will do over here is that I'm going to use the branch current formula. Okay, that's because today itself we did branch current, right? So let us use that particular expression. So this is my main current. Okay, and this particular part of the circuit, okay, I'm just putting it within the shaded region. Okay, now this particular part of the circuit is consisting of only two resistors connected in parallel. So easily you can apply branch current formula. So as per branch current formula, okay, the branch current I1 is equal to main current I into opposite branch resistance. What is it? 40 ohm divided by sum of the resistances. So what are those? 20 and 40. 20 plus 40. And that is equal to I. I is 8.57 into 40 divided by 60. That's about 5.71. So I1 is 5.71 amperes. Okay. Now I2 you can simply subtract the main current from the branch current. Okay. Or you can even apply, the branch current for resistance R2 as well. So let me do it in both ways. So I2 is I minus I1, right? Main current is 8.57 minus branch current is 5.71. That's about minus 2.85. Sorry, 2.85 amperes. Okay, or I2 you can find with the branch current formula, main current into resistance of the other branch, that is 20 ohm, divided by total resistance, 20 plus 40. Okay, so it is 8.57 into 20 by 60, or that is 1/3, right? 1/3 of 8.57. That is 2.85. You will get it as 2.85 amperes. Okay, so these two answers are agreeing with each other because the process remains the same. Okay, so either you can use the subtraction of currents, or you can again use the branch current. Okay, so you have found all the currents. You can say that now I through, or current through 20 ohm resistor is equal to I1, right? And what is I1? 5.71 amperes. Also, current through 40 ohm resistor is 2.85 amperes. Expected, right? Lesser the resistance, more will be the current. Greater the resistance, lesser will be the current flow. But when the current comes out of the node, it becomes the total of the sum of the two currents. Okay, so that's your current. Next, you have power consumption. Okay. So having known currents, you can find out the power consumption. So first, let me write power consumed in, say, 20 ohm resistor, which is equal to I1 square into R, or what is I1? I1 is 5.71, right? So 5.71 square into R1, correct? I mean, let me not write R1. You know that R is 20 ohm. Okay. So how much power value you will get it? So 5.71 square into 20. Okay, that is 652 watts. 0.08 watts. Okay, next you can write power consumed in 40 ohm resistance, that is I2 square into R, where R is the respective branch resistance. So what is I2? I2 is 2.85 square into R. Okay, so R is 40 ohm.
Sir, I got power in consumed in 20 ohm resistor as 641, sir.
641.
Yes, sir.
Okay, is it? Can you show me your calculation offline?
Yes, sir.
What happens, if you approximate the decimal point, it will give you,
Yes, I
yes.
rounded off to
Yeah.
decimal points.
Yeah. That's okay, man. That's okay. Okay. That's the reason I was saying, just to sail in the same boat, at least 2 digits after the decimal point you consider. Even then, no problem. You will be given with full marks on that. Okay. But as much as possible, keep 2 decimal, digits. Okay. Then finally, power consumed in 10 ohm resistance. Okay, so that is I square into R. Okay, what is I? The main current. That's 8.57 square into 10. 734 watts. 449 or 45 watts. Okay, so that's about the power consumption. Finally, you need to find voltage across 10 ohm. Okay, so voltage across 10 ohm, let us say V10, or what have we written in the circuit? Vx probably. Yeah, Vx we have written. Vx is equal to I into R. So current is the main current, 8.57, into the resistance value is 10 ohm. So it is 85.7 volts. Okay, 85.7 volts. So this is the solution. Now, while solving this problem, what I have done is in detail I have solved, right? So as you get the practice, you can skip off all this writing part and you can directly arrive at the solution. You don't have to do so much of writing part. Okay, you can just mention power consumed in 20 ohm resistor. You can simply write it as P10, okay, P40, and sorry, this is P20, right? P20, P40, and P10 ohm. Okay, it is understood that you are trying to find the power consumed in 20 ohm resistors. Okay, so all these shortcuts you can use in the coming classes. Okay, but as of now, let us go a little slow. Okay, fine. So that's your first problem. Hope you have understood. Okay, any doubts in this? No, right? Okay. So can I do a second problem? All right. Please note down the problem statement. Okay. So it says, if the total power dissipated total power dissipated. So dissipation is the synonym for consumption. Okay, power consumed in a circuit or power dissipated in a circuit conveys the same meaning. Okay, the total power dissipated in the circuit shown below. In the circuit shown below is 18 watts, 18 watts. Find the value of R. Find the value of R and its current. Find the value of R and its current. Okay. So in this particular problem, you have been given with a circuit diagram. Okay. So all what you need to find out is the unknown resistance value R and the current flow through R. Okay. So here you are, the circuit. 8 ohm in series with 4 ohm. Okay. So this is 8 ohm and this is 4 ohm. And you have a parallel branch which is consisting of again 2 series connected resistors. Okay. The first resistor is the unknown resistor having a resistance of R ohm. The second resistor is having a resistance of 16 ohm. And the voltage applied across the circuit is 12 volts. 12 volts. Okay. So this is the given circuit and you're supposed to find what is R, okay, and what is the current flow through it. Okay, since they are asking you to find out the current, what I will do, I will mark the currents. Okay, so first let us mark the current. Say this is I. Okay, so let's say through the upper branch I1 flows and through the lower branch I2 flows. Okay, so basically you need to find R value as well as I2 value. Okay, since I had to tell you what is the current which is flowing through R, so I have given appropriate, current value. Okay, which is I2 basically. Fine then. What do we know from the circuit? Okay, in the circuit, in the problem statement, they have told us about the total power dissipation. Okay, so the total power dissipation or the total power consumed in the circuit is 18 watts. So somehow you will have to make use of this particular given data. Okay, so what I will do, okay, let's say R equivalent is the total resistance of the circuit. Okay, let's find out what is R equivalent. Okay, from the power description. Now R equivalent basically represents the reduction of the 4 resistances into a single one. Okay, now through R equivalent, okay, basically the main current I flows. Okay, and the voltage 12 volts appears across R equivalent. Now we know voltage, we know power rating. Okay, so having known voltage and power consumption, you'll be able to find out R equivalent. That's because, okay, we have power P is equal to V square by R. Okay, now to our context, power P is V square divided by R equivalent. So, you can cross multiply and you can find out R equivalent. So R equivalent is basically V square divided by P. Okay, so what is V? V is 12 square, right? Because it is squaring of voltage. So it is 12 square divided by P. So the total power consumed in the circuit is 80. So it is basically 144 divided by 8. So 12 square divided by 18 gives R equivalent of 8 ohms. So R equivalent is 8 ohms. Take it as equation 1.
So current through R would be 0.5.
Exactly. Okay. So I2 is 0.5 amperes. If you have already solved this problem, well and good. Okay, fantastic. And R value, okay, you are supposed to get. Did anyone get it, R value?
So it's 8 ohms, sir.
That's right. Okay. If at all you have got, fantastic. Okay, you can just take a breather. You can just relax for a while. Let me solve the problem for the other students. Okay, don't worry, we will solve. Okay, fine. So R equivalent, you have got it as 8 ohm. Okay, now what is R equivalent? Okay, R equivalent is basically, consisting of two branches, right? You have branch 1, which is consisting of 8 ohm connected in series with 4 ohm. You also have branch 2, which is having R ohm connected in series with 16 ohm. So to find R equivalent, what we will do is we will first try to find out the equivalent resistance of each branch. So 8 plus 4 ohm. So this becomes 8 plus 4. That is 12 ohm. All right. On the other hand, in the lower arm of the circuit, the total resistance becomes R plus 16. So let me write it as R plus 16. Okay. So this R equivalent now can be easily found. No. In the upper branch, what do you have? You have an equivalent resistance of 12 ohm. And in the lower branch, you have an equivalent resistance of R plus 16 ohm. Okay. And this is your R equivalent. Okay, so basically you have a parallel combination. So R equivalent is 12 into R plus 16 divided by 12 plus R plus 16. Okay. And what is R equivalent? We have already found, right? R equivalent. From equation 1, we see that R equivalent is 8 ohm. So your left hand side is 8 ohm is equal to, you can start multiplying. It is 12R plus 224 probably. 12 into 16. 192, sorry, 192. Divided by 12 plus 16, that is 28, right? 6 to 8 and 28 plus R. Okay. Cross multiply. So you will have 8 into 28 plus R is equal to 12R plus 192. Solve this equation. Okay. So 8 into 28, that's 224 plus 8R is equal to 12R plus 192. So keep the like terms together. So let me keep R terms on the right hand side and the constants on the left hand side, or vice versa, doesn't matter. So I have 12R minus 8R, right? 12R minus 8R is equal to 224 minus 192. Okay. So how much will I get it? So 12 minus 8 is 4R is equal to 224 minus 192. So that's 32. Okay. Or R is equal to 32 by 4 or 8 ohm. Okay. So the unknown value of resistance is 8 ohm. Okay. Your friends have already obtained that particular answer. So R is 8 ohm. Okay. Now in the end, you need to find out the current flow through R. Okay. So let I2 be the current flow through R. Okay. So what you can do is, you can construct the equivalent circuit. Okay. So the upper branch is having 12 ohm resistance. Okay. Now the lower branch is having R plus 16 ohm, right? So what is R? R is 8 ohm. So it is 8 plus 16. Okay. So that is 24 ohms. Okay. and across this 12 volts is applied. Okay, across which 12 volts is applied, and you are supposed to find this particular current I2. So you can say I2 is equal to V divided by R. Voltage is 12, and R is 8 plus 16, that is 24. So it is 12 by 24 is half, or 0.5 amperes. Okay, so this is how you solve this particular problem. Okay, you're able to follow. Okay, so these are the simple problems. Okay, so in the next class, probably we can slightly raise the complexity, and we can take up a little more complex problems. Okay, so these are the typical problems what you can expect from DC circuits chapter. All right, hope you have understood. If you have any doubts, please revert. Okay, either you can revert in Google Classroom, or you can ping me in your WhatsApp group also. Okay, not the general group, the C section basic electricals group. Okay, so I will stop my lesson. Okay, today you are left with 3 minutes. If you have any doubts, you can just let me know.